So this is the unit circle. A unit circle is a circle with a radius of 1. Okay, that's where it comes from. So we are there's 3 rings around this circle. There is one that has little degree symbols on it. We're gonna fill those in. Those are degree values. Then the one next to it would represent the radians at those values. And then all the way on the outside are gonna be coordinate points. There is a pattern to this. If you do it with me now and you practice it, this should be the easiest thing you do all year as far as a quiz goes, okay? So we start with like the 4 quadrant angles that we did yesterday. I start by putting 0 all the way on the right above the line where the degree is, 90 at the top, 180 at the left, 270 at the bottom, and then it doubles all the way back around to 360 degrees, which goes under that 0. Then the pattern in each quadrant goes 30, 15, 15, 30. If you can memorize that pattern, you can fill in every single quadrant. So to the very first one, that 0, we add 30, we'd get 30. We'd add 15, we get 45. We add 15, we get 60. You add 30, you're at the 90. So let those quadrant little angles be checkpoints for you. Repeat the process again. Add 30, I get 120. Add 15, 135. Add 15, 150. Add 30, you hit 180. Do it again. Add 30, 210. Add 15, 225. Add 15, 240. Add 30, 270. Last time, add 30, 300. Add 15, 315. Add 15, 330. Add 30, you're at the 360. So if you want to write yourself in a corner somewhere, 30, 15, 15, 30, that's the pattern all the way around your unit circle. And we're 1/3 the way done, see? Painless. Now we're going to do the radians. So what are our 4 quadrant angles on the radians? What's the one on the right, where 0 is?
2 pi.
Well, the top would be 0, right? The bottom would be 2 pi. What's at the top?
Pi over 2.
Pi over 2. You don't have to use the little line as the fraction, but I do. It just makes it easier. What's on the left?
Pi.
Pi. What's on the bottom?
3 pi over 2.
3 pi over 2, and then all the way back around is your 2 pi. Now here comes the next pattern. Every angle closest to the x-axis is over 6. I'm going to say that again. Every angle closest to the x-axis, so just above it, just below it, is over 6. So I'm going to make this pi over 6. I'm going to make them all pi over 6 for now, and then I'm going to come back and fill in the ones that need to be changed. So the ones closest to the x-axis are over 6s. The ones closest to the y-axis are over 3s. So pi over 3, pi over 3, pi over 3, pi over 3.
I don't know.
All right, and then the in-betweens are over 4s. So this is the only, like the mistakes, silly mistakes are made on this quiz, but one is inverting the 3s and the 6s. If you're unsure, you're going to do this a couple times before you take that quiz, but if you're unsure, convert 30 degrees by multiplying by pi over 180. So we know how to convert from degrees to radians, right? Just multiply by pi over 180, and you would get pi over 6. Then you would know that that one goes there, and that pattern follows all the way around, okay? But you're basically taking something and dividing it by 6 instead of dividing it by 3, which would make it smaller, so it should make sense that it's the smaller angle. All right, so in the first quadrant, we leave the numerators as is. They are pi over 6, pi over 4, pi over 3. In the second quadrant, the numerator is 1 less than the denominator because we are less than 1. So in the second quadrant, the numerator is 1 less than the denominator. This would be 2 pi over 3, 3 pi over 4, and 5 pi over 6. In the third quadrant, we are now bigger than 1 pi. So the numerator is 1 more than the denominator. 7 pi over 6, 5 pi over 4, and 4 pi over 3. In the fourth quadrant, we are almost at 2. So there's 2 ways to memorize this. It is 1 less than double your denominator. Or you memorize 5, 7, 11. It is 1 less than double, which would make it 2 pi, the denominator. Or it's 5, 7, 11. 2/3 the way done. So you're sitting at a 67 right now. Now we do the coordinate points. Any questions before we get there? Okay. Now we do the coordinate points. So for every over 6, my coordinate point is root 3 over 2 and 1/2. And this comes from your special right triangle, 30, 60, 90. Every over 4 is root 2 over 2 and root 2 over 2, because that would be a 45, 45, 90 triangle, where the opposite and the adjacent are the same. And every over 3 is the reverse of the over 6, 1/2, and root 3 over 2. So fill those in. Leave space for the change of signs, though. So this is root 3 over 2 and 1/2. 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 Over 4s, root 2 over 2, 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 and then the over 3s, 1/2, root 3 over 2, 1/2, root 3 over 2, 1/2, root 3 over 2, 1/2, root 3 over 2. Now think about the positive and negative signs in these quadrants. If I'm in the first quadrant, what's true about my x and y values? They're both positive. Both x and y are positive. So we will eventually, at the end of today, add on sine and cosine here, but we're going to do x and y's right now, which means I leave all the ones in the first quadrant as positive. In the second quadrant, what's true about your x's and your y's? Good. X would be negative, y would be positive. So all my x values I have to change to be negative. What happens in the third quadrant?
X and Y is negative.
They're both negative. So negative, 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 negative. And in the fourth quadrant?
Y is negative.
Good. So x is positive and y is negative. And then the last thing to plug in is basically what defined the whole thing from the beginning, and that's the coordinate points moving out 1 in each direction. So if I move to the right 1, what would that coordinate point be?
1, 0.
Good. If I move up 1, what would that coordinate point be?
0, 1.
If I move left 1
Negative 1, 0.
and down 1,
0, negative 1.
good. That's it. Again, I'm going to change the corners. Eventually, we're going to get into sine, cosine, tangent, and we'll change the positive negatives to that. But for right now, we just need to understand the x and the y. So by quiz time, you will change those to sine, cosine, tangents, cotangent, cosecant, and what I missed? Cotangent, cosecant, and secant. But for today, just leave that as x and y. So we're going to add the tangents on, okay? You do not need to do this. This is not part of what will be on your quiz, but it will make your life a lot easier, okay? Every single angle, a tangent is the y over the x, right? So I could compute it every time. I could do y over x, y over x, y over x, or again, you could learn a pattern. All the over 3s, tangent is root 3. Think it only takes 1, 3 to make 3. All the over 6's tangent is root 3 over 3. 2 3's add up to 6. And the over 4's, if they are the same, they're always 1. So you could add those on all the way around your unit circle. You could put it on a note in the little corner for you. You don't need it for the quiz, but that's going to be super helpful for your test, okay? And then as you go around the circle at 0, it would be 0 over 1, which would be 0. At the top, 1 over 0, tangent would be undefined. On the left, it's back to being 0. And on the bottom, it's undefined. So, why do we learn the unit circle? And this is why, okay? You are going to learn to use that unit circle to answer questions like the sine at an angle, the cosine at an angle, the tangent at an angle, the cosecant, the secant, and the cotangent, okay? Sure. So this is the unit circle we just filled in. It is, like I said, based on a circle with a center at 0, 0 and a radius of 1. So we would move out, up, and down. And then these angles would be formed. This would be 30 degrees. This would be 90 degrees. This would be 60 degrees. My special right triangle would have been 1, root 3, and 2. And then I would do SOHCAHTOA. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. That is really in 4-3. So 4-3 is all right triangle trig. So today and Monday, we're going to do all of it as though it's unit circle trig. But there is a crossover. There are people that are like unit circle people, and there are people that are right triangle people. And you could choose between them for the most part. I don't care what you choose. You just got to figure out what clicks for you, okay? So this is basically what I just said. The length of that unit circle would be the radians. It would be going out in all directions 1. So no matter where you stop that angle, the end of it would be 1. And that's what forms your right triangle. There are 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. We abbreviate them as SIN, COS, and TAN. And CSE, SEC, and COT for the reciprocal functions. If you are using the unit circle coordinate points, which is why we add those on, then sine is the y, cosine is the x, tangent is the y over the x. So think C comes before S, cosine comes before sine, x comes before y, okay, if you can get confused. So if it's x and y, cosine is the first one, sine is the second one. C comes before S, x comes before y, okay? Tangent is y over x. And then all the reciprocal functions, you could literally do 1 over y or just do the reciprocal of sine. So take whatever sine is and flip it. Secant is the reciprocal of cosine. Take whatever the cosine is and flip it. And cotangent is either x over y or it's the reciprocal of tangent. Take whatever that tangent is and flip it. There's a lot of rationalization in this stuff. There's a lot of, eventually we're going to be having to combine our denominators. But for right now, the memorization comes from those coordinate points and then maybe flipping them and having to rationalize, okay? Remember that the cosine and the secant go together and the sine and the cosecant go together. The letters are always opposite. So the S doesn't go with S and the C doesn't go with C. They crisscross. People tend to forget that too. All right, so here it says use the figure at the right to find the trig functions at T. So we don't know the value of T. We know the coordinate point of T, which is 1/2 and root 3 over 2. So you should know the angle at T. What would that angle be? 60 degrees or pi over 3, okay? Find all 6 trig functions. So sine of T, cosine of T, tangent of T, cosecant of T, secant of T, and cotangent of T. So the sine is which coordinate, x or y? Nope. Sine is y. So root 3 over 2. Cosine is x, 1/2. Tangent would be y over x. So I'd get root 3 over 2 over 1/2. I'd have to keep, change, flip. just root 3. Now flip them all. The cosecant would be 2 over root 3, which has to get rationalized. 2 root 3 over 3. Good. Secant would be the reciprocal of 1/2. Good. And cotangent, I'd have to flip root 3 over 1. I'd get 1 over root 3, which gets rationalized to root 3 over 3. So sine, cosine, tangent, cosecant, secant, cotangent. You will never not rationalize, so don't forget to do it. Good so far. Take it a step further. Now it's not going to give you the point, it's giving you the angle. So find the point on the unit circle that corresponds to the real number t. If it's 2 pi over 3, it's an over 3, which means my coordinate point is already, I should have already know that, right? Over 3 is the 1/2 and root 3 over 2. And is 2 pi over 3 in the first, second, third, or fourth quadrant? Yes, sorry. Not Yes, second quadrant. And in the second quadrant, what's true about my signs? X is negative, Y is positive. So this is a negative 1/2 and root 3 over 2. If you had filled out your unit circle and you're staring at your unit circle, you could literally use that coordinate point from your unit circle. That's the whole point of it, okay? So now I would say, it just says find the point. So this is all we're doing. Negative 1/2 and then root 3 over 2. We're going to baby step our way all the way in. Yep. Because it's 2 pi over 3. In the first quadrant, it would be pi over 3. 2 pi over 3 is 1 less, like the numerator is 1 less. That's one way to look at it. The other way is it's bigger than 1/2, but less than 1. Because you want to be able to do that with any angle. Like, does it lie between 0 and 1/2, 1/2 and 1, 1, 1.5, or 1.5 and 2? Okay, now go a step further. It says evaluate, if possible, the sine, cosine, and tangent of the real number. So now it's giving me the angle, and I've got to just do those three, sine, cosine, tangent. We just had this one, right? 2 pi over 3 is negative 1/2 and root 3 over 2. So what's the sine there? Root 3 over 2. What's the cosine? Negative 1/2. Tangent is root 3 over 2 over negative 1/2. Keep, change, flip. Negative root 3. Go to B. T equals negative pi over 3. So first of all, it is an over 3. And an over 3 has the same coordinate point, 1/2 and root 3 over 2. If you just knew that alone and you didn't know where negative pi over 3 is, you could at least get the values. Your signs might be wrong, but at least get the values for sine, cosine, tangent, right? So I know the sine is the same as what we just did, root 3 over 2. The cosine is 1/2, and the tangent is root 3. Now I got to figure out what's positive and negative. So where does negative pi over 3 live? Good. Remember, there's two ways to do the negatives. One is find where it's positive. This would be pi over 3. Fold it in your mind, top to bottom, like a hamburger, and that's where the negative one would be. Or just move clockwise instead of counterclockwise. Pi over 3, I know, would be the first one I would hit moving in that direction. So I know it's fourth quadrant. And in the fourth quadrant, the x is positive, the y is negative, which means my cosine is positive this time, my sine is negative, and my tangent would be a y over an x, which means what's the sign? Negative. Good.
Why is it t equals?
It's the tangent of t. Oh, t is a way of telling you what the angle name is. That's all. Yep. So it'll say theta, it will say x, it will say t, it will say, that's just the name of the angle. All right, what's different with c that hasn't happened yet? You can reduce it, and you have to before you answer this question. You can't look at that and say it's an over 3, so it's the same coordinate point. It's not. 6 pi over 3 would be what?
2 pi.
2 pi. What's my coordinate point at 2 pi?
0, 0.
Nope.
0,
1, 0. Good. So sine, cosine, tangent. Sine is 0. Tangent is, or cosine is what? 1. Tangent is?
0.
Good. 0 over 1, which is 0. So if it was cotangent, let's say, then it would be undefined, which is why it says if possible. So your answer could be undefined. At the top, tangent's undefined, and at the bottom, tangent's undefined. Okay, so that can be an answer that you use. Questions on those? All right, domain and range of sine and cosine. So the domain of sine and cosine is the set of all real numbers, which means any values can be in there. You can go from +1 or -1 to +1. You can have zeros, you can have fractions, you can have anything in between. And what's more important is that they are cyclic, which means they repeat every 2 pi. So if I asked you for, let's say we stick to the same one, pi over 3, the coordinate point there would be 1/2 and √3 over 2. If I asked you for pi over 3's coterminal angle, how do I find a coterminal? Good. So if I added 2 pi here, I'd get pi over 3 plus 6 pi over 3, which would be 7 pi over 3. So if I asked you for the coordinate point at 7 pi over 3, what's true about it? It's going to be the same. So pi over 3 is here, right? 7 pi over 3 is the same point. And that's what it means by it's cyclic. It can happen over and over and over again using coterminal angles. So not every question you get, honestly, the majority of them will be unit circle based. They can be coterminal angles of your unit circle angles. So instead of it being 2 pi, I might ask for something at 4 pi or 6 pi or 8 pi, and those are all the same coordinate point. All right, so it says evaluate the trig function and use its period as a aid. So its period means that it repeats, okay? That they coterminal angles, that's what that means. So 13 pi over 6 is obviously not in my unit circle. Convert that to a mixed number. What would it be?
6.
Close. What's the mixed part? You got the fraction part. 2 pi over 6, right? Or 2 and 1/6 pi. Those are the same thing. So here's the trick with whole numbers. Even whole numbers are always on the right-hand side. Odd whole numbers are always on the left-hand side. Even are always on the right where 2 pi is. Odd are always on the left where pi is. So you can do this 2 ways. You can say, okay, I'm going to go all the way around my circle once. That's 2 pi. And then go past it to pi over 6. And stop. That coordinate point would be, do we remember the over 6?
Square root 3 over 2.
Good. So the sign there would be what?
Positive.
Positive. What's the value?
Oh, for the sign?
Mm-hmm.
Oh, 1/2.
Good. The other way to do the mixed numbers is to just start wherever the whole number is and then just use the fractional part. So if I had 2 pi over 6, instead of even going all the way around once, I'm literally just going to start on the right because the evens start on the right. And then ask yourself, is what's there bigger than 1/2 or less than 1/2? If it's less than 1/2, it's the first quadrant it hits after it. If it's bigger than 1/2, it's going to cross into the next quadrant. So if this was 17 pi over 6, convert that into a mixed number. It's what? 2 and 5 pi over 6. So the 2 tells me start over here on the right. And is 5 pi over 6 bigger than 1/2 or less than 1/2? Bigger than 1/2. So I go into the second quadrant and I would use that over 6, which means that it's going to be a negative √3 over 2 and a positive 1/2.
Is it always going to be on the unit circle after you turn it into a mixed number?
If it is an exact answer and you don't have your calculator.
Okay.
So you could find this of any random angle using a calculator. But if it's if it's like without, which it's going to be. If it's going to be evaluate this without a calculator, then it's going to be unit circle based. Yep. All right, so cosine 5 pi. Based on what I just told you about the even and odds, where's 5 pi? On the left. I could go, this is 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. Not so bad. If you get 15 pi, that's not going to be fun to do. Odds are left. What's the coordinate point on the left?
-1, 0.
-1, 0. What's the cosine there?
-1.
-1. Questions so far? All right, I'm going to stop there. Okay, now we're going to change these. So now that we know sine, cosine, tangent, in that first quadrant, the acronym is, and I'll teach you this again next week, but the acronym that will help you remember this is all students take calculus. So if you start in the top right quadrant, it's A, and then you move counterclockwise, all students take calculus. In the first quadrant, they are all positive. So sine, cosine, tangent, cosecant, secant, and cotangent are all positive. You could literally write the word all there. In the second quadrant, the S tells you of the original 3 trig functions, which is positive. So if you think about it, the y, that makes sense. The y means sine is positive. So sine is positive, and its reciprocal function, which is cosecant, is positive. Everything else is negative. The cosine, the secant, the tangent, and the cotangent are all negative. So the letter in that quadrant represents which of the original 3 trig functions is positive. The T stands for tangent. If I put a negative over a negative, it's going to give me a positive. So tangent is positive and its reciprocal function, which is cotangent. Negative would be everything else. Sine, cosecant, cosine, and secant. And in the last quadrant, the C, which stands for cosine, is positive. Cosine and its reciprocal function, which is secant. And then everything else is negative. Sine, cosecant, tangent, cotangent. So that is how you'll fill it in on Tuesday. Again, you don't need the tangents, but you do need the corner ones to be in trig function format, not x and y's.